All right, so today we're going to do the long division part. Again, we did this last year, just like everything else we've done, basically. And then tomorrow we'll do the synthetic. The synthetic's much quicker and easier, but we're going to do long as well, just so we know how to do both ways. Okay, so here's a regular long division problem like you're used to doing, or maybe you never learned it, but we'll go through that again, and I'll show you that it's very similar to a polynomial long division problem, which these are the type we're going to be doing here, the type on the right. Okay, so when I look and talk to myself about doing the one on the left here, 277 divided by 12, I ask myself, how many times is 12? I know it doesn't go into 2, so I ask myself, how many times is 12 go into 27? And you guys know that's a 2, right? I got to fix this so you guys on the side don't have to crank your neck. So that's where this green 2 comes from. 27 divided by 12 is 2, so that 2 goes up there. Then I take this 2 and I multiply it by the 12 to get this 24 here under the 277. At this point, okay, I subtract that 24 from the 27. And that's where this 3 comes from. All right? The 7 is just dropping that N7 straight down next to the 3. Okay? If this number here, this 3, is bigger than 12, then I didn't get the biggest number that goes into, how many times 12 goes into 27. All right, then I ask myself the same thing. How many times does 12 go into 37? And I know that's 3. And then I do the same thing. I go 3 times 12 to get this 36. And then I subtract again. And that's where that 1 comes from. Okay? And usually, here's how we're going to make our answer. The answer would be 23. And my remainder is 1, so I put 1, in this stuff over here, we're going to put plus. In normal math, normal numbers like this, we wouldn't put the plus, but it'd be 1 over what I divided by 12. So over here, my remainder, I'll put 1 over the x plus 2. All right, but we'll go through that in a minute. But you guys understand this method here? Again, you should know that, but sometimes you weren't really taught long division, depending on what class you're in, I guess. But that's the basics for long division. And over here, we do the same thing, all right? Now, when we do this, I'll do this, get my highlighter out. Okay? All I worry about when I see a bunch of terms, this is a trinomial divided by a binomial. We'll always just have binomials here for these long division, but this could be more than 3 terms. It could be 4 or 5 or 6. Okay, that doesn't really matter. The first thing you got to make sure of is that the dividend here, the blue one, is in the right order, from the highest exponent down to the constant. So x to the second, x to the first, and then the constant. If I had an x to the third, that would be in front of the 2x squared. Okay? Also, if something's missing, maybe this was just 2x squared plus 7. The 7x wasn't there. I have to put an x to hold that spot, like that place. So what I do is I put a 0 in front of it. So if this just was 2x squared plus 7, I would write 2x squared plus 0x plus 7, just to hold that spot, because an x will show up. If I have an x squared, an x will show up. If I have an x cubed, an x squared, and an x, and then a constant. If I'm missing a constant, okay, Maybe it was just 2x squared plus 7x. Then I'd add a 0 on the end for that spot. Just to hold, because everything will line up then for you when you do your subtraction. Okay, so that's important. You got to make sure you do that. Okay? Same thing out here. If this was x squared plus 2, I would write x squared plus 0x plus 2 to hold that spot, because they're going to show up. So that just keeps everything lined up for you when you do this part. When you go 12, or 2 times 12 to get to 24, and then you want to subtract, all your like terms will line up then if you make sure you do that. So that's the first thing. Make sure you don't have to add any zeros somewhere. Okay? So, when I do this problem, all I worry about is the first term of the dividend and the divisor. So all I'm worried about is 2x squared and x. And I just ask myself, what's 2x squared divided by x? And you would all tell me what? 2x. And that's where that green 2x came from. The 2x squared divided by the x gives you that 2x. Just like the 27 divided by 12 gave us the 2. Now what do we do with this 2 and the 12 then? What was that step? To get 24, what did I do? Multiply. Well, I'm going to do the same thing. I'm going to multiply 2x times x. That's where that 2x squared comes from. But I also have to multiply 2x times the 2. That's where that 4x came from. So it's like distributing. Does that make sense? Now what did I do after I multiplied 2 times 12 and got to 24? I subtracted, right? Well, that's what I'm going to do over here. I'm going to subtract. Okay? What's always going to happen to this first term? These two. Every time I do this, when I subtract, what should happen? They should cancel out, right? They should be exactly the same. Okay? So those would cancel out. And then what is 7x minus 4x? That's where that 3x came from. Just like 27 minus 24, that's where that 3 came from. Same procedure. Okay? And then we drop the 7 down, and what we're going to do here is drop this plus 7 down after that 3x. Okay? And then all I think about, again, is this 3x and that x. What's 3x divided by x? Three x divided by x is 3, thank you. So that's where that 3 came from there. Again, 3x divided by x is where I got that green 3 up top. And then I just do the same thing. I'm going to multiply 3 times x to get that 3x, and 3 times 2 to get that 6. And then what do? I subtract. Same procedure. Okay? That's what I did here. We had 37 divided by 12 was 3. 3 times 12 is 36. And then we subtracted to get that 1. Well, 3x minus 3x, those will cancel. That's what's supposed to happen. And then 7 minus 6 is the 1. Okay, so here's our answer. 2x plus 3. And then since it's a positive 1, it's 1 over, for my remainder, x plus 2. So those are basically the same problem. This didn't have the variables in it, that's all. Just a regular number divided by a number. Same procedure. Okay? So you always just think about the first term divided by the first term. First term divided by the first term. To get those two. Multiply, subtract. Okay? questions on either one of those? Okay. So let's do another one together. What do I got to do first? I see a negative y squared, a y cubed, then the 25. What did they do down here? First of all, put it in the correct order, right? From highest exponent down to the constant. We also have to add the 0y. If there's a y cubed, there's got to be a y squared, there's got to be a y, and then the constant. So we had to add that spot. It's always plus 0, whatever you need. It's got to be in the correct order, though. Highest, then go down by 1 to the constant. So that's the first thing. Put this in the right order and add any zeros that you have to add. So that's what it looks like, the problem, when you do the long division. Any questions on the setup? We good so far? Okay, so on the next slide, I got it all set up. Okay, so remember, all I'm worrying about, that divided by that. Don't worry about anything else in the first step. So, what's 2y cubed divided by 1y?
2y squared.
Right. 2y squared. So I put that up here. Okay. Now what do I do with this 2y squared? I multiply it by both of those. So 2y squared times 2y is 2y cubed. And 2y squared times negative 3 is negative 6y squared. See how things are lining up right now? Okay. At this point, I subtract. Okay. 2y cubed minus 2y cubed, they'll cancel. That's what you want to happen. Now be careful here. What's negative 1 minus a negative 6? What's minus a negative? Addition, right? So that's negative 1 plus 6, which would be 5 y squared. Then you bring down the plus 0y. And then we start over. I take this divided by y. What's 5y squared divided by y? Five y squared divided by y.
5y.
5y. And it's positive 5y, so I put plus 5y here. And then I distribute it. 5y times y, this is the multiplication part, and 5y times negative 3. And then I subtract again. What happens to the 5y squared? They cancel. What's 0 minus a negative 15? That would be plus 15, right? So 0 plus 15 would be 15y. Again, see that y showed up. That's why I had to add that 0y in there. So everything lines up for you, all your like terms. Okay? And then I drop down the plus 25. And then I start over again. I take the 15y divided by y, which is what, Tanner? Right, 15y divided by y, so that's a positive 15, so that's what goes up there. So Braden, what do I do with this 15 then? Right. So 15 times y and 15 times negative 3. And then we subtract. Okay. The 15y's cancel. That's what should happen. And then my remainder is 25 minus a negative 45, which is 25 plus 45, which would be 70. So I'd put at the end, plus, since it was positive 70, and then over the y minus 3. Questions? Guys, remember this from last year, hopefully. Okay, so in this one, when we first saw it, it wasn't in the right order, and it was missing a y. So that's the first thing we did, put it in the right order, and added that 0y. Remember, it's got to have a 0 in front. It's like adding 0, right? So we're not changing it. Don't just put a y there, then that's like adding a 1. That's changing it. Okay? And then we write it. And then all I worry about is this first term divided by the first term to get d. First term divided by the first term. Multiply. Basically, we're distributing and then subtracting. Okay? And then they have, this slide's got the answer. Same thing there. Okay? Questions on that example? Make sense to you? All right, I would like you to try one on your own so I can come around if you get stuck. So try it, and then we'll go over it real quick. It won't take us long. I went slow on that first one.
I could see it on my laptop, have it on there, but on there when it was like, yeah.
You guys ready to go over this one? All right, do I need to add any zeros to this one? No, it's all set, right? So we got the 3x plus 1 and the 15x squared plus 8x minus 1. So remember, all I'm worried about is the 15x squared and the 3x. What's 15x squared divided by 3x? Come on. 5x, thank you. So put the 5x up top. And then I multiply 5x times 3x gives me the 15x squared, and the 5x times 1 is 5x, and then I subtract. Those will cancel, that's what I want to happen. And then 8x minus 5x is 3x, and then we bring down the minus 12. And then again, I start over. I take 3x divided by 3x, which is what? 1. That's a positive 1, so I put plus 1. Okay, and then I take 1 times 3x and 1 times 1 and subtract. Okay, my 3x's cancel. What's a negative 12 minus 1?
Negative 13.
Thank you. That's my remainder. So up top here, I just put, since it's negative 13, I just put minus 13 over 3x plus 1. If you put plus and then negative 13 over 3x plus 1, that's okay. If you guys want to do plus for your remainder, just remember, if it's a negative, then put a negative with your number. Does that make sense? Yes.
How do you know if you need to add a zero?
If something's missing, like this one had a y cubed, a y squared, but there was no y, we have to add that in there. But this one, we had an x squared and an x, and then the constant, so we didn't have to. Welcome. Any other questions? Does that make sense? That's all we're doing. 4 long division problems for homework. We good?
Mm-hmm.
All right. Good start. Good job. That's our assignment. Got the 15 minutes. Might be able to get a couple of them done, maybe all of it, depending on how good at this you are. Remember, put it in the right order. Add the zeros if you need to.